Hello students, I just want to follow up on the one workshop we had 11th of October. One of the questions was also how to use Nand, if the question comes up, how to use Nand gates to convert Boolean expressions, and then how do we use Nand gates then to just implement those expressions. So the question can come up, convert the following expression to be implemented only by Nand gates, and how do we do this? So firstly, we can use what we call the Nand gate equivalencies. Because Nand gates are what we call universal gates, they can represent any gate at all. So first off, if we have this, Nand gate uses the inverter, like so. So the input is wired to the two inputs of the Nand gate, and the output is then inverted. For me, this is one of the most important ones you need to know. Here you use a Nand gate as an AND gate. So here you NAND them together, and then you invert it, double bar, take the bars away, so you can use it as an AND gate. Here you use it as an OR gate, and also as a NOR gate, if you would like to do that. But once again, the most important one you need to know is using the Nand gate as the inverter gate. Using the Nand gate equivalencies might be confusing, because if you have 3 or 4 OR operators, then you use 3 Nand gates per OR operator, which becomes confusing and complex. The best thing to do is to use what we call the double complement method. So you write your Boolean expression down, f equals abc or ab whatever, and then you place 2 lines, double complement line, over the expression. So why do we use a double complement? 2 reasons mainly. One is adding a double complement doesn't add anything to the expression, as the double complement cancels out. Remember your Boolean simplification laws. If you have a double complement above an expression, they cancel out. So we're not adding anything to the expression. And secondly, we can use De Morgan's theorem to change the sign in the SOP or PS expression. So if we have ORs in the SOP expression, we can break the line, change the sign to an AND operator, and then just split the complement line. So here we have an example. So here we have an SOP, 3 variable SOPs with A, B, and C. And now I tell you, okay, so implement this only using Nand gates. So first thing you do, we draw the double complement lines, and then we use De Morgan to break the line and change the sign. So we break the lines over the ORs and change the signs to and breaking these lines. So now we have this expression here, which we can implement with just Nand gates. A, B, and C are NANDed together. A goes through a complement, a Nand gate complement, and is then NANDed with B and C. A is NANDed with B not C, and B goes through a Nand gate first, and then all 3 of these outputs are then NANDed together in one big final Nand gate. So this also works with NOR gates. If we have a POS expression like this, double complement, break the line to change the sign. These are actually wrong. These should be ORs instead of ANDs, because we broke the line there, so it should be an OR operator there. And then we only left with OR operators and inverters, and we can implement this with NOR gates. Okay, so let's do a couple. So we have this. Now for this, it doesn't matter that it's not in the standard form. As you will see, this is not the standard form. Not all the terms contain all the other terms. It doesn't matter. So we have this expression here. We draw the double complement line on top, break the line, change the signs, and now this we can implement with Nand gates. So B goes through a Nand gate by itself and gets complemented. C and D goes through a Nand gate. A, B, and C goes through a Nand gate, and A goes through a Nand gate by itself. And then all these 4 expressions outputs are then going through one Nand gate, and we can do it like that. Now for the NOR gate, so there's POS, double complement, and then break the line, change the signs. Here we broke the signs, and now this is just a complement NAND gate, complement NAND gate, complement NAND gate, complement NAND gate, A and B going through a NAND gate, and C and D going through a NAND gate, and then all of those outputs going through one big NAND gate. So, in summary, give the expression a double complement. Use De Morgan to break the line and change the signs we don't want. If you're using a NAND gate, ensure all the OR operators are changed. And when you're using NOR gates, ensure all the AND operators are changed. This is usually with SOPs, where we use OR, and POS, where we use AND gates. So, break the line, change the sign, and then draw that circuit. I hope this clears up a little bit of the confusion.